Hello everyone, welcome to our last week together, week number 8 in our term of Bio 120. Just think, after your winter break, you'll be starting a new school year and you'll be getting closer to your graduation date. Won't that be exciting? This week, there we go. I'll get it in a second. Last week we took a look at ecosystems. You had an optional set of discussion board postings that you could participate in about eutrophication, and this is aging out bodies of water, and also it includes algal blooms that happen in all sorts of bodies of water, everything from ponds and lakes to rivers to the ocean. Yeah, algal blooms can happen anywhere. And this causes devastating consequences if there is an algal bloom. So we discussed that in your discussion board postings, but the main thing that you had to do last week was your final project. Hopefully everybody's gotten those turned in, because I told you last week what a big assignment this is. 260 points out of 1,000 points, more than a quarter of your grade, is that final project in week 7. So please do get these in before our deadline for this course. This week is about population ecology. A population is members of the same species that live together in a particular place at a particular time. Now the time span can be, billions of years if you're talking about bacteria, or it can be a week, or it can be an hour. It just depends on what you're talking about. But there are all different kinds of ways that we study populations. One example that I'd like to give is when I went to Africa back in August, we met with researchers who were studying the wild dog population in Botswana. So there were 88 wild dogs in 4 contiguous countries around this area in Botswana: Namibia, Angola, Zambia, Botswana, I think it was. Might have also included Zimbabwe, but there were only this many wild dogs, and we were located in a place where there was one pack of wild African dogs. There were 22 adults and there were 13 puppies in this particular pack, and the alpha male and alpha female both had radio collars, and researchers had been studying these wild dogs and their behaviors. They were a very successful pack, and we got to see them several times. That was very interesting. I think they were my most favorite animals out of any that I saw because of how they worked together as a community. So that's a way to study population ecology. But you don't have to study animals. You can study a type of tree that grows somewhere, or an endangered fungus that's important for an ecosystem, or bacteria in your microbiome. There are lots of ways to study populations and lots of different types. This week we're going to concentrate on the human population on the planet Earth. And we've got a very interesting animation and interactive map, and you need to go watch that video and examine it. Do the interactive part down at the bottom. I think it says animate the map, and it's a little arrow. Try that because it's very interesting. You can stop it all along the way to see what's happening in history, especially when you get population losses on the planet. Look at the 1300s and the 1600s in particular to see what was happening then when the population declined. In Europe in the 1600s, I believe that the population declined by about 40% because of something in particular. So take a look at that. Okay, so you're going to watch the video, you're going to do the little animation, you're going to explore the map on your own, and then you've got a journal entry to complete. You're going to discuss whether exponential growth for any organism on the planet is possible to continue ad infinitum, so into eternity. And of course the answers are going to be no. The population's going to run out of food, right? Yeah. So, it just makes common sense. But so why can't you have exponential growth? This is going to be important because we're going to examine what's happening with the human population. And it sort of feels like we're going to exponential growth. Review the meaning of the map and what the dots mean and where the most dots are showing up as we look at how the human population has changed over time and how it's going to change into the future. And then you're going to discuss the consequences, environmental and human consequences of the human population reaching 9 billion. It was just a few years ago that we hit the 8 billion mark, and it's estimated that in 2050, which is not that many years away, we will hit the 9 billion mark. So we're going to increase in just a matter of maybe 30 years, 1 billion people on the planet, which is just unreal, but it's true. That is what's happening. And what are the consequences of this? Think back to what happened in 2020. Didn't we have COVID? I think it's estimated that 7 million people on the planet died because of COVID the first time, the first go-round. So why is that true? Why did a new disease pop up? Because new diseases are always popping up. That's just the way it happens. Viruses mutate. Viruses evolve. Bacteria do this. People are moving closer together. They're more crowded, and that means that it's easier to transmit diseases. So there are all kinds of factors that come into play, and we saw it happen in our lifetime in 2020 with COVID. So do consider things like that when you're writing your journal article. And then, so that's the only thing that you have to do this week. No discussion board postings, just your journal entry on the human population and that interactive map. Final thoughts and tasks. Please fill out your course evaluations. Please, please, please. That helps me out. That helps me learn how to be a better instructor. It tells my team lead and my dean how I'm doing as an instructor here at SNHU, and they need to know that. So please fill out your course evaluations. They're very important to me, and I appreciate it if you do take the time to do that. And I can't see who posts anything, and I don't even get to look at them until about 2 weeks after the course finishes. So, and I still can't see who wrote what. Just so you know that. The last day to turn in any work for this course is Sunday, December 21st, this upcoming Sunday, a week from today. I'm making this video on Sunday. December 21st by 11:59 p.m. If you hit the midnight mark, or go over into Monday, you cannot upload anything else. Be aware of that. I can't upload it either. You can't send it to me and I can put it. Nope, I can't do that either. All I can do is grade for the next 2 days. Right up until almost Christmas Eve, which is unreal, but that's how it's happening this year. Get everything turned in. If you're having any trouble, if you can't get that last final project in because you're having some difficulties, the family situation, you're sick, because everybody's getting sick right now, please let me know and we can submit an incomplete request. But let me know before the end of the term. That's the other thing. It has to be turned in before the end of the term. If you need anything, all you have to do is email me, m.sigmon@snhu.edu. I'll get it out. That's all you need to do, and we can take care of whatever is happening. All right. With that being said, I appreciate you. We've had a wonderful term. It's been so good to get to know you through your projects, through your work, through interactions with you. I wish you the very best in the future. And if you ever need a reference, a letter of recommendation, whatever, keep me in mind, m.sigmon@snhu.edu. All you have to do is go back and look through your courses and find me and email me. And I'll be glad to do that for you. I hope that you have a very happy holiday, and please do let me know if you need anything during this last week.